All right, so we're going to talk about two more ways of solving quadratics. So far we've talked about factoring. Now we're going to talk about the square root property and completing the square. But before we get to that, let's talk about the nature of square roots. So let's consider x squared equals 9. Right? So what squared gets you 9? Hopefully you can pretty much see that 3 can get you 9. Right? Because 3 squared is 9. However, is there something else squared that can get you 9? Well, what about negative 3, right? Because negative 3 squared is the same as negative 3 times negative 3, which is also positive 9. So if we have something like this, right, where we have x squared is 9, we know that x can either be positive or negative 9. So another way to write this, right, could be that x is positive 9, or positive square root of 9, which is 3, and that x is negative square root of 9, which is negative 3, right? So here's two different ways that we can rewrite this one statement, which goes right into what our square root property is. So assume that u is an algebraic expression. So there's just some expression, could be x plus 2, could be whatever. And that d is a positive real number. Then if u squared equals d, right? So if we go back and see if x squared equals 9, right? We could say x equals square root of 9 or x equals negative square root of 9. So using our same logic, right? If u squared is d, then u is the square root of d, or u is the negative square root of d. So another way we could write this is that u is plus or minus the square root of d. So it would be positive d, square root of d, or negative square root of d. So whichever way you like to write it, you can write it that way. No problem at all. So that's the square root property. So let's go through the steps and see how we can solve quadratics using the square root property. So first, you need to make sure to rewrite the form in u squared equals d, right? Where u is some algebraic expression. So basically, we want to make sure to isolate the squared term, moving everything else to the other side. Notice this works if u is your only variable. So don't need that u. If u is your only variable and d is a real number. So after that, we can use our square root property. So we know that u is going to be the positive square root of d, and u is the negative square root of d. And then from there, we want to solve the equations. And then, of course, step 4 is always just checking. But we don't have to do that, but we absolutely can. So let's look at example number 1. So 3x squared equals 18. So we don't have something squared equals something, right? We need u squared equals d. We don't have that. We have 3 times something squared is d. So first thing we need to do is get rid of this 3. So we can do that by dividing both sides by 3, right? So we have x squared is 6. Then we can use our formula, right? Take the square root. So that means that we have x is the positive square root of 6, and x is the negative square root of 6. Now, can we simplify? We always have to simplify radicals every single time we look at them. So 6 can be simplified into 2 and 3. 2 can't be simplified anymore. 3 can't be simplified anymore. Since there's no pairs, that is simplified. So that's as simplified as it can go. So then our solution set is going to be the square root of 6, negative square root of 6. And that's our answer. If we want, we can definitely check it, right? So we can plug it back in. So 3 times the square root of 6 squared. So square root of 6 squared, if you square root and square something, those just cancel each other, right? Which means we have 3 times 6, which is just 18. Likewise, if you have 3 times the negative square root of 6 squared, right? The squares and square roots cancel. The negative sign also becomes positive, right? Because negative times negative is positive. So once again, we get 3 times 6, which is 18. So we got our answer. There we go. All right, let's do another one. So this time, once again, we need to isolate the square, right? The x squared. So we can add the 7 to the other side and then divide everything by 2. So x squared is 7 divided by 2. All right. Then we get our two equations. X is the positive square root of 7 over 2. X is the negative square root of 7 over 2. However, we have to rationalize these equations, right? Because remember, we can't have a radical in the denominator. So we can split that up into the square root of 7 over the square root of 2. Then remember to rationalize, we multiply by the denominator, right? The square root of the 2 in this case. So we get the square root of 14, or excuse me, the square root of 7 times 2 over the square root of 2 times 2. If you notice in the top, nothing changes, right? You can't break up 7, you can't break up 2, and there's no pairs to be had, so we can just multiply those together to get the square root of 14. On the bottom, we do have a pair, so we can take that out to be 2. And then obviously, if this is the positive form, we can see that this is just going to be the negative form, negative square root of 14 over 2. So our solution set is going to be positive square root of 14 over 2, negative square root of 14 over 2. All right. Number 3. So once again, we need to isolate our x squared, step 1. So we can get 9x squared is negative 25. So x squared is negative 25 over 9. Then we take the square root. But we can't take the square root, right? Not to get a real number, right? Square root of a negative doesn't make any sense. And that's why we said D has to be positive. When you have something like this, right, you have to have a positive number for the square to equal. So something like this, we cannot take the square root of a negative. So we have no real solution. Remember, that just means the real number. We don't have a real number solution, no real solution. So our solution set would just be the empty set, right? Open, close. Or you could write it like this, either way. Number 4, last one. All right, so this time we already have the square, right? So we could multiply this out, FOIL it out if we really wanted to, distribute it out, but we don't need to, right? We already got a square. It's something squared equals 5. So if we have something squared equals 5, right, then that means that something equals positive 5, square root of 5, and that something equals negative square root of 5. So if we want to solve for x, step 3, we just have x equals, add 1 to both sides, 1 plus the square root of 5, 1 equals 1 minus the square root of 5. So our solution set is 1 plus the square root of 5, 1 minus the square root of 5. And if you ended up with something like x equals the square root of 5 plus 1, that's fine too. Yeah, or x equals negative 5 plus 1, square root of 5 plus 1, that's also fine. I just think this looks a little prettier. Have a little bit of symmetry here. But if you're like this, totally okay. All right, and that was it. So let's talk about completing the square. So I'm going to just walk you through kind of the reasoning of why we're doing this. I think it's helpful, especially when you have to memorize something, to know why you have to memorize it. What's the point? Where did this come from? So bear with me. We're going to do 2 of examples to try to see how we get this number. Okay, so let's assume that we don't have something nice like this, right? We don't have it. What if we have a square that also has an x inside, right? So x squared plus 8x, right? Well, remember, when we talked about the square root method, when we're using the square root property, that can only be the variable, right? The thing squared is the only thing that is the variable, right? So you can't just move the x to the other side, because then you have x's on 2 different sides of an equal sign. That's not great, right? So what we can do is we could turn this into a square, right? So basically what we're saying is, what could you add to this to make it a square? It would be x plus something squared, right? Well, let's call this something. We can call it m, right? So x plus m squared is going to be what? What would we have to add to make this, when we factor it, a square? So if we factored this out, right, we see that we would have, well, we can actually write it out. So x plus m times x plus m. So that's x times x plus m plus m times x plus m. So we get x squared plus mx plus mx plus m squared, right? Because you can switch those around, that's no problem. So we get x squared plus 2mx plus m squared. So this is equal to, we said, x squared plus 8x plus something, right? Both of these should be the same thing. Well, if you notice, right, in front of this x is a 2m, but in front of this x is an 8, which means that 8 has to equal 2m. So that means that m is 8 over 2, which is 4. Now we see, right, this box right here is all by itself. This doesn't have an x. The one that doesn't have an x over here is m. And since we said m was 4, that box has to be 4 squared, which is 16. So the number to add to make this square is 16. And if you notice, right, let's actually add 16. So x squared plus 8x plus 16, right? So if we factored it, what 2 numbers multiply gets you 16, adds gets you 8. Hopefully you saw that it's 4, right? 4 times 4 is 16. 4 plus 4 is 8, which means that we have a perfect square. All right. So let's do another one. So now let's try x squared minus 6x, right? So what do we have to add to get us x plus something squared? What do we have to add to get a perfect square? So when we factor it out, we end up with some perfect square, so we can use the square root property. Well, again, if we do the right side, so that's x plus m times x plus m. So that's x times x plus m times x plus m. So we get x squared plus mx plus mx plus m squared. So x squared plus 2mx plus m squared. That seems familiar, and it should, because it's the exact same thing every single time, right? So we see that this is going to equal x squared minus 6x plus whatever our thing is that we need to add, right? So again, the middle numbers should equal each other, right? The thing in front of the x's should equal. Negative 6 should equal 2m. So then m is going to be negative 6 over 2, which is negative 3. And then, of course, the number by itself should also be the same thing. M, or that number, is going to be m squared. which means that that number is negative 3 squared, which is 9. So 9 is the answer. If you add 9, you should end up with a perfect square, which if we see, right, if we add 9 to that, what two numbers add, or sorry, what two numbers multiplied gets you 9, adds gives you negative 6. Hopefully we see that would be negative 3. Negative 3 times negative 3 is positive 9. Negative 3 minus 3, or plus negative 3, negative 6. So once again, we have a perfect square. All right, so let's see, what did we do to get this number? How did we figure this number out? Let's go back to the first one. So we saw that it is m squared. And how did we get m, right? M was this number divided by 2, right? So if we have this written out as normal in the standard form, right, that would be x squared plus bx. So we took the number in front of x and we divided it by 2 to get our m. But we wanted m squared for our final answer, right? So then we just squared that number, right? 8 divided by 2 is 4, and then we squared 4. Let's look at the second time we did it. So here, if we had this x squared plus bx, we see this is negative 6. So to find m, we took that number, divided it by 2 to get negative 3, and then we needed m squared, so we squared it to get 9. So this number right here, that is what you have to add to complete the square. You need to add b divided by 2 squared. That's the shortcut to do all this. So if all this was really confusing and you don't really understand any of it, that's totally okay. This is all you need to know. So for completing the square, if you have an x squared plus bx as a binomial, so there's nothing in front of your x squared. That's super important. There's nothing in front of x squared. Then by adding b over 2 squared, it will result in a perfect trinomial, right? And a perfect square. So if you add b over 2 squared, right, you can factor out x plus b over 2 squared. And if you notice, that's exactly what we did, right? Because we said b over 2 in this case was negative 3. That was that m. And we ended up with x minus 3, right? And here, over here in the first one, we said that b divided by 2 was 4. That was our m. And when we factored out, we had x plus 4, x plus 4. So if you understood that, awesome. If not, that's totally okay. You can always memorize. Memorizing is fine too. All right, so let's just kind of do some examples. So what term should be added to make it a perfect square? So how do we complete the square? Completing the square means what number do you add to be able to factor it out? And then once we do it, let's factor. So for completing the square, that's how I shortcut it. CTS, completing the square. You take your b term, divide by 2, and square it. So b in this case is 10. So we got 10 divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25. So we need to add 25. So x squared plus 10x plus 25. So that should get us a perfect square. And when we actually factor it, right? If you remember the thing, it should be plus whatever b divided by 2 is, whatever you're squaring, which is just 5, right? 5 times 5 is 25. 5 plus 5 is 10. All right, let's do another one. So we get x squared minus 7x. So completing the square, we have b divided by 2 squared. B is negative 7. So negative 7 divided by 2 squared. There's really no way to simplify this time. So we just square the top, square the bottom. So negative 7 squared is 49. 2 squared is 4. So we're going to add 49 over 4. So x squared minus 7x plus 49 over 4. And if you remember, right, that's going to factor to x and then whatever number you just squared, right? X minus 7/2 squared. All right. Last one, completing the square. So if we want to complete the square, you take b divided by 2, square it. So this time we have a fraction within a fraction. So 3/5 divided by 2 squared. So if you want to remember how to divide, right? Remember 3/5 divided by 2. That's what this says. So it's the same as 3/5 times 1/2, which is 3/10. So this is the same as 3/10 squared, which is 3 times 3 is 9. 10 times 10 is 100. 9 over 100. So that's the number we're going to add. And then we get x squared plus 35x, 3 over 5x plus 9 over 100. So the way we factor it, if you know what number you squared, right, then that's the number that's going to be in your perfect square binomial. And that's it. All right, so let's learn how to complete the square, solving these quadratics by completing the square. So, step for step. So first, you need to make sure to isolate the x squared plus bx to one side. So x squared plus bx should be on one side, everything else should be on the other side. So this is what's going to happen if you can't factor. All right, so if you have something that just doesn't factor well, we can use this. So, step 2, find the term that completes the square. And make sure to add it to both sides of the equation. That's super important. That's what students forget. So, underline, square, highlight, do whatever you need to do, right? You need to make sure that you're adding it to both sides of the equation. Step 4, we're going to factor. Step 3 is factoring. Step 4 is using the square root property. So then we just continued to factor, or we use the square root property and then solve. All right. So let's solve by completing the square. So notice, there's nothing that works, right, by factoring. What two numbers multiply to get you 4, adds get you -6? It doesn't work, right? 2 and 2, that equals 4. -2, -2, also -4. 4 and 1, we get 5. -4, -1, we get -5, right? So none of these work. So factoring is not going to work, so maybe we should try completing the square. All right, so step 1, make sure to get everything off to the other side. So all you want is your x squared plus 6x, or plus bx. So we subtract off the 4 to get -4. So then we want to complete the square. So we have b divided by 2 squared. So in this case, it's -6 divided by 2 squared. -6 divided by 2 is -3. -3 squared is 9. So step 2, you want to add 9 to both sides of your equation. Adding 9, adding 9. Making sure to add 9 to the to the right side is actually going to make you be able to do this problem. So we see that the right side is just +5. Step 3, factor. So when we factor the right side, we should see that that's going to be x minus 3 squared equals 5, right? So just the number we squared from our factoring, or from our completing the square. Then we do the square root property, right? So we see that this is going to be that x minus 3 equals +5. X minus 3 equals -5. Which means that if we add 3 to both sides, that's 3, square root. That should be square root, my bad. Yeah, so 3 plus the square root of 5 And then x is 3 minus the square root of 5. So a solution set. If we wanted to simplify, we could also see, if you notice, that this is going to be 3 plus or minus the square root of 5. But you can obviously write it out 2 different ways as well. Let's try another one. So step 1, get your number off to the side. So we get x squared plus 4x equals positive 1. Step 2, complete the square. So it's b divided by 2 squared. So we see that that's 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So we want to add 4 to both sides of this equation. So factoring the one side, we get x plus 2. That's the number we squared and are completing the square. And then the other side, we get 5 again. So if we want to take the square root, you can do it the way we've been doing it, totally okay. You can also just say x plus 2 equals plus or minus the square root of 5. And then you can say x equals negative 2 plus or minus the square root of 5. If you don't like this, that's totally okay. We can keep writing it the other way. So our solution set is negative 2 plus square root of 5, negative 2 minus square root of 5. Just multiple ways of writing this. Whichever way you like, do it that way. All right, 2 more problems, and then we are calling it a day for this lesson. All right, step 1, move the number over to the side. So we get x squared plus 9x equals 3. Step 2, complete the square. Right? So 9 divided by 2 squared. So 9 divided by 2, that doesn't come out to a nice even number. So 9 squared is 81. 2 squared is 4. So we are going to add 81 over 4 to both sides of the equation. So to do the left side, right, we just know that's going to be x plus 9 over 2 squared, right? That's the number we squared. To get the other side, we need to make sure to have a common denominator. So this is 3 over 1. So we can see 4 is going to be the common denominator. So you can multiply this by 4 on the bottom and 4 on the top. Right? So 1 times 4 is 4. 3 times 4 is 12. So we get 4 on the bottom, and then we get 93 on the top. So we see that we get x plus 9 over 2 is plus or minus the square root of 93 over 4. But this doesn't work, right? Because we have a radical in the denominator. So we need to simplify that. So we get the square root of 39 over the square root of 4. Well, the square root of 4, can that be simplified? Yeah, that's 2 and 2, right? So you can take out a 2. Can 93 be simplified? So that's 3 and 31. 31 can't simplify anymore. 3 can't simplify anymore. So that's simplified as that goes. So we see that that's plus or minus the square root of 93 over 2. And then lastly, right, so we get x plus 9 over 2 is plus or minus the square root of 93 over 2. So we can just subtract to the other side, and we end up with negative 9 over 2 plus or minus the square root of 93 over 2. So we can use like this if you want. If you really want to, you can also combine the fraction. Right? Either way works. But either way, our solution set is negative 9/2 plus square root of 93 over 2, negative 9/2 minus square root of 93 over 2. Last problem. All right. Step 1. Get the 1 on the other side. X squared minus 3x equals negative 1. Step 2. Complete the square. So negative 3 divided by 2 squared. Can't simplify inside, so negative 3 squared is 9. 2 squared is 4. So we're going to add 9/4 to both sides of this equation. On the left side, that simplifies down to x minus 3/2 squared. On the other side, we need to have a common denominator. So we see that that's once again going to be 4. So we multiply it by 4 over 4. And we see that when we add it together, we get 5/4. So when we take the square root method, we see that it's plus or minus the square root of 5/4. We can break that up into the square root of 5 over the square root of 4. Since we already said the square root of 4 was 2, and you can't break up 5 anymore, that's plus or minus the square root of 5 over 2. So just rewriting what we already established, right? So we can rewrite that as x equals positive 3/2 plus or minus the square root of 5 over 2. So solution set. Three plus or minus the square root of 5 over 2. That's another way we could write it. All right. It is important that you know all of these methods. For this class, it's important that you learn all of this. So if you are in my next class, for instance, college algebra or something higher, I don't care how you do it, but the purpose of this class is to learn and be tested on every single method. So you will need to know how to do this. So might as well learn now. So if you have any questions over these methods that we've talked about, as always, please shoot me a text, shoot me an email, whatever you need. Come to office hours, we can figure this out.